Hello, it's Mrs. Pound, and I am back with our third type of rock. We've already talked about igneous rock and sedimentary rock. Now we're talking about the last category, which is metamorphic rock. So let's get started. Our objectives today are to identify metamorphic rock and discuss how it forms, identify the agents of change in the process of metamorphism, distinguish features and examples of two categories of metamorphic rock, and compare and contrast the different types of metamorphism. So metamorphism is the process of change in the structure and mineral composition of a rock. So you're saying, well, why am I showing butterfly chrysalises in the background? Well, it's because that we also call that metamorphism. It's change in the butterfly over its life cycle. And so I just wanted to remind you that this is a word that you already know, except for now we are applying it to rocks instead of insects. Now, metamorphic rock is rock that's formed from existing rocks that have been heated and squeezed. So they are being changed. They already exist, but they're being changed by heat and pressure. So how metamorphic rocks form? They form as a result of intense heat and pressure being applied to igneous rock, sedimentary rock, or other metamorphic rocks. So they already exist and they are changing their form. There are three types of metamorphism that will cause this to occur. The first is called dynamic metamorphism, dynamic meaning motion. This is produced by mechanical forces with direct pressure as their primary cause. So forces pressing, such as along a fault, such as during an earthquake, or some other catastrophic event like that, will cause folding of the rock layers, as you can see in the picture here. You can see these folds that zigzag back and forth. That is caused by pressure being applied to that rock. There is also contact metamorphism. This occurs when the heat of magma, such as an igneous intrusion, comes in contact with existing rock. An igneous intrusion is inside of the earth, and it's hot magma that is pushing up into the other rock, such as perhaps other igneous rock, metamorphic rock already, or sedimentary rock, and is heating it up and changing the crystal structure. And that is commonly found with marble, which is my background. It produces a local effect, only changing rocks that are near or touching the magma. So that's why it's called contact. It has to touch. There's also regional metamorphism. This occurs when large regions of the Earth's crust are affected by high temperatures and high pressures. This oftentimes is caused by dynamic metamorphism. Minerals and rock types change with regional metamorphism along with folding and rock layer deformation in the area. Most metamorphic rock is formed through regional metamorphism. And contact metamorphism is often found near regional metamorphism. That's because this is occurring in areas where there's probably some kind of volcanic or earthquake type activities where there is some magma perhaps seeping up to the surface. There are two categories of metamorphic rock, and we will look at these in class. There's foliated rock. This is the rock with distinct bands of minerals that have been heated and squeezed into parallel layers. And you can see those parallel bands here in this picture in the background. Some examples are slate, schist, and gneiss. And we're going to look at those in class. There's also non-foliated rock. This is the rock without distinct layers or bands. And some examples are quartzite and marble. And the marble you saw earlier, that white and swirly kind of background, definitely not banded. And there's some quartzite in the background here. And you can see the crystal structure is very large and it looks kind of melted together. And so that is quartzite. Okay, so last but not least, let's go to your reference tables. This is on page 7, and this is the scheme for metamorphic rock identification. And we can see a lot of different things here. If we take a look at the texture, we have foliated and non-foliated. And under foliated, there are two types. There's mineral alignment and there's banding. And if it also shows the composition of the rocks, the type of metamorphism, some general comments about the rocks, their names, and their map symbols. So if we look at the composition, that can help us somewhat, because if we go across here, slate is predominantly mica. So we can see that, and we can see the different compositions, so that can help us. Now, we also see that if it's foliated, that is regional metamorphism. Heat and pressure both increase. We can also go down here, and here are non-foliated. It has the grain size, it has, again, the composition, the type of metamorphism comments, and the type of the rock name, excuse me. And we can see here that this comes from quartz, so it's quartzite. Marble comes from calcite and dolomite. So this is actually from limestone generally. And metaconglomerate would be basically metamorphized conglomerate rock. And so we can use this to help us figure out what kind of metamorphic rocks we have. So our objectives were to identify metamorphic rock and discuss how it forms, and we're going to be identifying some of those rocks in class, identify the agents of change in the process of metamorphism, distinguish features and examples of two categories of metamorphic rock, which are foliated and are non-foliated. Foliation is leaves, and so the layers are like layers of leaves. And to compare and contrast the different types of metamorphism, which were the dynamic metamorphism, the contact metamorphism, and the regional metamorphism. So write down your 5 questions and be ready to look at some rock samples in class.